Hello again everyone, welcome back to ptet.chemistry channel. In this tutorial video, I'll continue this section B topical MCQ on 10.7, which is on carboxylic acids and its derivative, mostly esters really. So the four multiple choice options are A, being related to 1, 2 and 3 that are relevant to whatever they're asking. 1 and 2 would be B, and C will be 2 and 3, and D will be only 1 is relevant to whatever they're asking. So in this section B kind of topical MCQ, because of these options, we always go and check option number 2 first by default logic. Okay, so it's something that your school teacher will have raised out with you in lessons as well as in practice sessions. So let's get started with this question. So we have this monosodium glutamate. So you know it as a flavor enhancer. So in Southeast Asian country, we call it Ajinomoto. It's come from the Japanese actually. So in Japanese food, they have that thing they call the umami flavor, which result of well, it's not natural. It's not sweetness, right? It's like that missing flavor, you know. So Ajinomoto is like a replacement for that. It's a flavor enhancer to recreate that umami flavor. You will have heard about it in a lot in Chinese restaurant cooking, yeah. Okay, so it's quite common in Chinese food. Well, the westernized Chinese food, because it's not supposed to have Ajinomoto to begin with, right? Because that is man-made. Anyway, so we can prepare it starting from the following compound. So they're asking for what set of reagent and conditions could be used to prepare it. So when you think about it, if you look at it carefully, you got 1, 2, 3, 4. So there's the carboxylic acid, that's the amine there. This is your 1, 2, 3, 4, and you have an additional carbon, 5. Okay, so you have added 1 extra carbon, so 5 carbon total, and there are only 4 carbon here. If I number this 1, 2, 3, 4, there'll be 1, 2, 3, 4, 5. So we have added 1 carbon. We can be thinking about, we can be thinking about CN, but then that can exist in 2 different forms. We can do nucleophilic addition, or we can do nucleophilic substitution. When we do nucleophilic addition, we will be thinking about ketones and aldehydes. We don't have ketones and aldehydes. When we do nucleophilic substitution, we'll be thinking about halogenoalkane. We do have a halogenoalkane, a chloroalkane. So this is the one that we're going to use, alright? So if we check number 2 first, number 2 is saying that if you hit it with sodium metanoate, then the metanoate could act as a nucleophile and attack this chlorine. The question is, could it or could it not? Alright? So you only have HCO or minus. You have that, and it will not attack that thing, because if I show it very clearly, so you have H and H. If I show R, delta minus delta plus, your charge is on the oxygen. So when you draw the mechanism, it will be from the oxygen to there, and if that reaction follows that, okay, I'm just saying if it proceeds, so I'm just going to use dotted arrow because I'm not sure whether it proceeds or not. But of course you can try and draw it out, and what do you get? You get this. That is strange. That is not what is shown here, right? Because the charge there is minus, and you have formed oxygen carbon bond. So that's the important thing there. You have formed oxygen carbon bond, whereas these are the original oxygen carbon bond, and what you want is you want to form carbon-carbon, because this is carbon 4. You want to form carbon-carbon bond, whereas you here you form oxygen carbon bond. Number 2 is definitely wrong. If you draw it out, you can see it. Alright, number 2 is wrong. There can only be one option. Alright, heating under reflux with NaOH can hydrolyze the CCl, but no extra carbon. So you want to add 1 extra carbon. If you just replace the Cl with OH, you still end up with 4 carbon. You don't end up with 5 carbon. So moving on to the next question. So we have fats and grease. So when you pan fry something or you deep fry something, they build up on pans. Those are what we call esters. So fats and grease, you have known that they are esters. Where you have what do they say? Glycerol plus 3 fatty acids. So if I remember this correctly, this was what I learned in biology. That will give you fats, and fats contain ester functional group. Alright, the alcohol bit and the carboxylic acid bit, condensation to form ester. Okay, so it will kick out unknown number of water because that is a condensation reaction to form esters. Alright, so pans which are dirty from fats or grease, you can clean them using a reagent that will react with the ester group. So this is a hydrolysis of the ester group. What may be used to clean such pan by this reaction? Okay, so when you have esters, esters can be hydrolyzed by acid or bases. Acid or bases. But esters will not react further with alcohol. So 2 is entirely wrong because there is no more, it's got no, ester cannot form hydrogen bond. Okay, so esters cannot form hydrogen bond. So they can't dissolve in ethanol at all. Alright. Plus, if you think about ester, this is dipoles on the oxygen which are electronegative, but there is no hydrogen bonded to the oxygen at all. So no hydrogen bond. They cannot form hydrogen bond between themselves. They cannot form hydrogen bond with water. Okay, but they can form permanent dipoles with alcohol. All right. Hang on. They can form permanent dipole with alcohol. So although you can form permanent dipoles with the OH there, but you gotta remember these are the fatty acids bit. It has really long. So these are hydrophobic, non-polar. Okay, people who do A-level biology, you will really have heard of hydrophobic and non-polar groups at the end of your fats, and those make it really difficult to be washed away by this polar solvent, which is ethanol. So I stand by what I said earlier, like esters can't form hydrogen bond, they are not going to be washed away easily by ethanol. It's the vinegar, which is a aqueous ethanoic acid, that can do your acidic hydrolysis of your ester. So what happens is you can hydrolyze it, and when you hydrolyze them, you get carboxylic acid and alcohol, both of which can be washed away with water because the alcohol and carboxylic acid can form hydrogen bond. Alright, so option D, which is based on 2 being incorrect, only 1 is correct. This next one can react with carboxylic acid, but you no longer have carboxylic acid when you have fats because fats are just esters. So moving on to this next question, so we have aspirin. So aspirin is obviously a well-known painkiller. We've known the properties for centuries, and it's got this structure here. So you can see there is a carboxylic acid, and I hope you can see there is an ester, and this bit is just the benzene ring. So I think in modern paper they won't necessarily ask you benzene anymore, because back then this benzene is now part of A2 chemistry. So back then the division or the division of AS and A2 were a bit confusing back then. All right. So these days you wouldn't expect questions to involve benzene, but you should know your 2,4-dinitrophenylhydrazine, which is not related to this question, but this is 2,4-DNPH, which you use to test for aldehyde and ketones. It's still got a benzene ring, so maybe not. They can still ask you 2,4-DNPH because this chemistry is related to your AS carbonyl compound, aldehyde and ketones. So maybe they could still ask you the benzene ring in AS, alright? But the main functional group here, you see they didn't touch on benzene, so they touch on carboxylic acid, which I shown you here, carboxylic acid. I've shown you there's an ester. I have not shown you there's an alcohol because there's no alcohol here. Alright, there's no alcohol at all. This is not alcohol because this OH is bonded to this carbon that has got a carbonyl. So this overall on its own is called carboxylic acid. It's not called alcohol. Alright. Similarly, this is not called ketone on its own because it's bonded to a COOH. Alright. So 2 and 3, there's option C. In this next question, we have ferrilic acid. This is an antioxidant. That means it prevents oxidation. It doesn't like to be oxidized. Well, hang on, antioxidant. Yeah, it prevents oxidation. All right, it prevents oxidation. So what do we have here? We have alkene. We have carboxylic acid. And again, I hope you can see there's a benzene ring. So that is your benzene ring. And this was also from around 2008, just like previous question. So perhaps back then they still ask you questions on benzene ring as well. This thing is an alcohol, but it's a special alcohol. It's alcohol bonded to benzene. You will learn more this in A2 chemistry. It's called phenol. Alright? So people in upper 6, people already, preparing to do their A-levels, they will have realized that it is a phenol. This is a strange one as well. You don't do this in A-level. When you have an O bonded to R and R dash, where R dash is just carbon derivative, that is called an ether. So there are some syllabus in the UK A-level that actually cover this specifically. So oxygen bonded to 2 carbon, 1 there and 1 there, that is called an ether. But this question is asking you with this part of the molecule. So they're basically saying ignore the other part, ignore this part, just this part of the molecule. So we're just looking at alkene and carboxylic acid. Alright, we're just looking at this and this. Alright, so doesn't matter what is there, we're just looking at these reactions here. Acidified KMNO form, yes, because you got carbon-carbon, alkene oxidation, which can give you diols if you use cold, dilute, aqueous, acidified, MnO4 minus. And of course you can get oxidative cleavage of the carbon-carbon double bond. Then this will break and you will get one product out of this, you get another product out of this. That is under hot, concentrated, acidified, MnO4 minus, right? So 2 is correct. NaOH is the base. You can think of it as an alkali. It can neutralize. It can neutralize a carboxylic acid. So 1 is correct. You have a HBr, you have an alkene, right? So you can get an alkene, electrophilic addition. That is one of your case study in AS, delta plus, delta minus, rich in electron attacks that, and so on and so forth. So all 3 of them can react with this part of the molecule. Alright? This is the last question of this 5 question section B topical MCQ series. So this organic compound decolorizes aqueous bromine. So we are looking at the presence of unsaturation, okay, which in your A-level syllabus refer to carbon-carbon double bond, but unsaturation basically means not carbon-carbon single, alright? Reacts with sodium to produce hydrogen. So it has OH. I'm not saying it is alcohol, I'm saying it has OH hydroxyl. Be very careful here, because it could be alcohol. It could also be carboxylic acid, because even carboxylic acid reacts with sodium to give you hydrogen gas as well, because it's got the hydroxyl OH. These are functional group. This is just OH hydroxyl group. Alright. So these are 3 carbon compound. By looking at it, I should be thinking about this and this. Alright. So let me try and draw it out. C3H4O2. If I try to draw 3 carbon acid, that will be 3H, 1, 2, 3, because carbon from 4 bonds is 3 hydrogen there. Carbon from 4 bond, You already seen 2. There's 2 hydrogen there. So 3 hydrogen plus 2 hydrogen is 5, plus 1 is 6. O2. C3H6O2. So none of these is the 3-carbon acid, alright? But I forgot one thing. Carbon-carbon double bond. Do you see I have 2 extra hydrogen? If I have 1 carbon-carbon double bond, then I will lose the 2 hydrogen. Then I will get that. 1, 2 hydrogen, because now you have double bond. 2 hydrogen plus 1 hydrogen is 3, 4. C3H4O2. Number 2 is perfectly legit because I have carbon-carbon double bond, and I have a carboxylic acid that has a OH that can react with sodium to give me hydrogen gas. Alright? Of course, you can balance the equation. If you are asked in a theory paper, you need to learn how to balance the equation and write out the structural formula or whatever. Balance the equation, that means you get half hydrogen molecule because there's only 1 H plus there. This is what you call a redox reaction. So what type of reaction is this? This is a redox reaction. Sodium 0. This is sodium metal, so it's sodium 0 oxidation state. This is sodium plus 1. This is hydrogen as an element. This is hydrogen as in a compound, as an acid H plus. Alright. Now I gotta check number 1. Number 1 has got only 1 oxygen, so I can be thinking about alcohol, something like this. But instead of the carboxylic acid, I have alcohols. Maybe I can just draw it here. If I have alcohol, but I also have double bond, then I'll have 1, 2, 3 carbon, and I'll have 1, 2, 3, 4, 5, 6, and I have 1 oxygen, C3H6O. It has got hydroxyl group, it's got alkene. When you add sodium, it will form, well, let me show you. When I have that, when I add sodium, I will get this thing. This is called sodium alkoxide. Alkoxide anion is what you get when you react alcohol with reactive metal. And you also get half H2 as a gas because you only give out one of the H. This is again what you call a redox reaction. So a lot of students don't know about this. Work in terms of oxidation number because you are in A level, so you should be able to do oxidation number and seeing that there's a reduction and there's oxidation. This is redox, just like this is redox. Alright. And number 3, C3H8O. I hope you can see that this is C3H6O. It's got 2 more hydrogen and 1 less oxygen. That's because instead of the carbon-oxygen double bond, you have 2 extra hydrogen there. From this alcohol, which is this one, to C3H8O, you need 2 more hydrogen plus 2 more hydrogen. You already have this molecule. Where can you get 2 more hydrogen? When you add across the double bond. So that means C3H8O is going to be that with no carbon-carbon double bond. And if there is no carbon-carbon double bond, in order for you to get the add hydrogen, that means it won't decolorize aqueous bromine because you don't have unsaturation. So only 1 and 2 are correct, and that is option B. Alright, so that's the end of this 5-question tutorial series. If that was helpful, click the button on the bottom right, subscribe to the channel, share the channel with your friends, your class group chat, your I don't know, your social network, and your juniors perhaps as well, who are about to enter A-levels or who are going to do their paper 1 AS component, or even anyone else you think this channel might be useful for. Alright, so thanks for sharing, thanks for watching, and I'll see you in the next video.